Hello everyone. In this video we're going to be solving a Diophantine equation, an equation with integer solutions. We have x times the quantity x plus 1 equals y squared, where x and y are integers, and we're going to try to find solutions for x and y. So we're going to be solving for x and y values. What else could we solve for, right? So to solve this problem, I'm going to talk about a couple different approaches that we can possibly use, and let's see how that goes. So we have this interesting product, x and x plus 1, which are two consecutive integers. And we want their products to be the square of another integer, right? So how does this work? So there's a couple ways to go about it. If you have a quadratic equation, you can solve it with the quadratic formula, right? So let's go ahead and expand this first. X squared plus x equals y squared. Great. Now, after we distribute, we notice that this can be written in two ways, either as a quadratic in y or in x. There's no point in really writing it as a quadratic in y, because from here, y is basically going to be plus minus the square root of x squared plus x, which is not very interesting, is it? You can test numbers, but it's not going to be a good general solution. We want something that we could generate solutions from. Okay, so instead, let's focus on, and this is going to be our first method, let's focus on solving for x, which is actually more interesting, don't you think? So let's go ahead and subtract y squared. And then our goal is to solve for x using the quadratic formula. So x is equal to negative b plus minus the square root of, b is 1 in this case, the coefficient of x, right? So this is quadratic in x. B squared minus 4ac, which is the discriminant, right? B squared minus 4ac. A is 1, c is negative y squared, so we're going to have to change this to a plus sign, and that'll be y squared. And then, of course, you have to divide it by 2a, which is just 2 because a is equal to 1. Make sense? Clear enough? Some people say, oh, you go too fast. We don't get it. Well, you can slow it down yourself. So this is the x value, but what is that supposed to mean, right? For which y values this is going to be an integer? That is the million-dollar question. So here's what we're going to focus on now. Inside the radical, we have 1 plus 4y squared. In order for x to be an integer, we want this expression under the radical to be a perfect square. So this needs to be a perfect square. Let's call this, I don't know, k squared, where k is another integer, right? So this gives us the following. 1 plus 4y squared equals k squared. Now, is this better than the original equation? Absolutely, because guess what? We can go ahead and subtract 4y squared from both sides and switch sides here. K squared minus 4y squared equals 1. And the left-hand side is factorable by difference of two squares. For those of you who are new to difference of two squares, I'm going to explain what that means so it's clear enough. You can factor a squared minus b squared as a plus b times a minus b. Great. So a is k in this case, and b is 2y, because 4y squared is the square of 2y, right? So we can now factor this as k plus 2y multiplied by k minus 2y. And that is equal to y. I mean 1, right? Great. Now, what is good about it is that 1 can only be factored into two factors, 1 and 1 or negative 1 and negative 1. There's only two ways to do it. Very limited, right? So let's go ahead and take it from here. This can be a 1 and this can be a 1. Let's talk about what that means in a little bit. Or it can be a negative 1 and negative 1. So far, so good? All right. Now, let's go ahead and take a look at it from a systems perspective. If k plus 2y is equal to 1 and k minus 2y is equal to 1 at the same time, then we can go ahead and solve this system, right? Can't we? By using elimination. It calls for elimination, doesn't it? Add these two equations, 2y cancels out. You get 2k equals 1 and k equals 1/2. Uh-oh, Houston, we have a problem. But let's go ahead and plug in k and find y value. If you plug it into the first equation, you get 1/2 plus 1/2 equals 1. So 2y needs to be 1/2. In other words, y needs to be 1/4. You see what the problem is? y is not an integer. So we cannot accept it, reject, right? What does that mean though? That means 1 and 1 is not going to produce any meaningful solutions. Let's go ahead and check the second one, -1 and -1. Maybe that is going to help, right? You wish. K plus 2y is equal to -1. K minus 2y is equal to -1. You probably noticed that, oops, I just realized I made a mistake. Okay, never mind. I don't know how I got 1 by adding 1 and 1. Let's go back a little bit, rewind the tape, but I'm not going to cut it. K equals 1 from here. Great. So K equals 1 looks like a good solution, but we still need to find y. If K is 1, then y needs to be 0. Okay, awesome. What about x? If y is equal to 0, then you're going to get something like this, right? X times x plus 1 equals 0. And from here you get x equals 0 and x equals -1. What is that supposed to mean? It just means that 0, 0 is a solution. As you can check easily, if you plug in 0 and 0, you'll get an equality. And if x is equal to -1, then y can still be 0, right? Because that's where it comes from. So we got two ordered pairs from 1, 1. Okay, now let's go ahead and check -1 and -1. That should also give us more solutions, hopefully. Let's check it out. -1 and -1. We're going to add them again, same way. 2k is -2, k is -1. Let's go ahead and plug it in. Now, how do you find y from k? We have an equation, either one of these or the original one. If k is -1, you get y equals 0. Again, the same thing. And if y is 0, you know what happens. So this is nothing new. It gives us the exact same thing, which means we only end up with two solutions. All right, so far so good. Well, this brings us to the end of the first method, but not to the end of the video. So stick around because we're going to do the second method, which hopefully you're going to like. I like the second method better, but it's for you to decide. So let's just pick it up from where we distributed the x over the x plus 1. Now here's y equation. I want to use a different approach. So what was the first approach? The first approach used a quadratic equation in x. And then from there, we used the fact that the expression under the radical needs to be a perfect square, which gives us a factorable equation, which is very easy to solve. What would happen if it didn't give us a factorable equation, but instead it gave us something like this? Let's just say on the other side, suppose you got the following. What would you do? Well, this is a Pell's equation, and guess what? I made a video about Pell's equation. You can go ahead and check that one out. I'll try to link it down below if I can find it, or if someone else can find it for you. For me, I mean for everyone else, that would be awesome because I'm lazy. Okay? So here's the second method. We're going to go ahead and do something that is very commonly done. And I know some people are going to be like, where on earth does this come from, right? Some people always react like, and that's perfectly fine, I understand, because if you didn't know this trick, how on earth would you think of that, right? But here's how it works, and it makes a lot of sense. We're going to multiply both sides by 4, and you'll see in a little bit why this is helpful. Now, on the left-hand side, you get 4x squared plus 4x, and on the right-hand side, you get 4y squared. Great, so far so good, right? Now, here's what we're going to do. We're going to turn the left-hand side to a perfect square. To do that, we're going to add 1 to both sides, because you should know if you add 1 here, the left-hand side becomes a perfect square. Don't you see that? It becomes 2x plus 1. I guess I didn't see that either. Plus 1 squared. And that is equal to 4y squared plus 1. And guess what? This brings us to the same point. Why? Because 2x plus 1 is an integer if x is an integer. And then from here, we can safely say that, hey, suppose you replace 2x plus 1 with something like maybe m. And so you get m squared equals 4y squared plus 1. And what is that supposed to mean? It just means that you got a factorable equation again. But we arrived at this solution a little differently, of course. We didn't use the same ideas. But at the end, it turns out to be the same thing. And guess what? You're going to be finding the exact same ordered pairs from here, namely 0, 0, and -1, 0. And there are no other integer solutions. And notice that I also included the negative ones. And if you know of a third way to do it, please let us know in the comment section down below. I'd be curious to know. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe. Take care. Don't forget to check out my other channel, aplusbi, and my shorts channel, aplusbi focuses on complex numbers. You can learn a lot from them. And let me know what you think. Until next time, bye-bye.